Okay. And the first equation, equalities, and add it. Then what you get is, well, this is 1, this is 2, so I times 2, 1 plus 2. Then the left hand side, you can write down x0, x of f xy dx minus x0, x of f x y0 dy, no dx. That's okay? And now the next one is, you must be a little bit careful about that. So how you get it? So you get a v plus I s. And that's you rewrite it I times s plus iv. Yeah? Therefore, you can write right hand side y0 to y of f of x, y, and Cauchy write in this way, I dy. Yeah, you can just write here I. And then minus of y0, y of f x0, y, I dy. Okay. So you can actually then taking sort of the real part of this and imaginary part of this equality, you come back to this. So this is essentially equivalent expression. And now what this mean? So Cauchy wrote an I dy, so that means that something that he wanted to integrate in the imaginary directions in some sense. Okay. So here x0 plus I by 0, and here large x plus I by 0, and here is x plus I by, and here is x0 plus I. And then we can easily interpret this part. So x0, x of f xy, for example, what means that you just integrate here. And this part. The x is just integrate. Okay? So this is clear. So actually it's better to choose change the sign here, minus, plus, minus, plus. Then this means if you take a minus, that means you integrate the opposite direction. Simple. So now we want to interpret this part. What does it mean? So for example, x0, x of f x y0, y, 0y, I dy. What it does mean? It's something like integrate here, because the x is fixed. So I really want something like integration here. And also y0, y of f x, y, I, dy seems something integral here. Okay. So you have to clarify what that means. And actually, the Cauchy in is in the following way. So if you consider the real path of something phi x and y is psi x, okay? And x plus iy is the complex variables. So, this is not x, this is t. And t is defined some point at, for example, t equal 1, or something like this. Not necessary. Probably it's better to say that here a to b is defined. Okay. And then I want to integrate this function. So x plus iy. So this gives you the some path in the complex plane. So it started from phi a plus I psi a, and it ended phi a, phi b plus I psi b. So it moves in there, here. And we call this the path gamma. Then I want to, actually Cauchy wanted to define some function, integrals, along this gamma. Okay? And this is nothing but, actually Cauchy did at the beginning in not so nice way. So he had a lot of effort to clarify his ideas, but somehow what he did is something. So this is the definition of this integral along the some path of the complex value function is given by a to b f here phi t plus I psi t, and then now phi prime t plus I psi prime t dt. So just make a very formal way. So he made this as a definition of the integral along the path. Okay? So this is a very nice way. So let's come back to our original one. So, what is this path? How can you express this path? Joining x plus iy0 to x plus iy. The simplest way is just, what is the simplest way? X plus I, just take t, and t moves to y0 to dash y. So this is, so therefore your phi t is a constant function, and the psi t is just a linear function. Then psi dash t is 0, and phi prime t is 0, psi prime t is just 1. So here, this is 0 and this is 1, so I dt comes in. So actually what you get is y0, y to f here, okay, and x plus it and I dt. Okay. And if you write it y as t as y, precisely that's integral here. It's okay? Okay. And also similarly you can find it. And then what this formula is? So move the right hand side to the left hand side, everything. Then what you get is, sorry, I'm a bit bad, minus equals 0. We got this formula. And then this formula is nothing but now our, so just highlight in this way. So it's a very bad way to explain that. X0 plus IY0, and here X plus IY, here X0 plus, sorry, X plus IY0. Here is X0 plus IY. So just consider this rectangular, and just consider the path going to first this direction, and this direction, and this direction, and this direction. And then what this result means that if you integrate this dx plus IY, it should be 0. This is what that first Cauchy proved. And then Cauchy equations are all, in a sense, pass from here to here. All pass. Then Cauchy considered all passes gamma tilde in your rectangular, joining x plus IY0 to x plus IY. So any path from x0 plus IY0 going to x plus IY, but only condition is this path is contained in this rectangle. Then he showed that this integral is independent of gamma tilde. I mean that if you choose any path, the value is the same. Actually, you can, therefore, you can show that, for example, this gives you the integral here. This is one path. So this value is actually same as x0 to x of f of x plus I y0 dx plus y0y of f now x plus iy and I dy. This is the value. And this is a special type of the Cauchy's theorems today, we call it. Because another way to formulate is, inside of this rectangle, you start from the one path here, gamma 1 tilde, and you have two paths, gamma 2 tilde. And you can join this path in the following way. Start from gamma 1 tilde and go back using this gamma 2 tilde. Then you have a closed curve. Then this implies along this closed curve, so I write sometimes gamma 1 and gamma 2 inverse tilde. This is it. Then f, sorry, not small f, that's a large f. That's all. Here's